Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 academic students who are studying the analytic geometry part of the course. In this video, we'll look at how to find the shortest distance point to a line. So here I've drawn randomly a point and a line. So let's give them some names. We're going to call the point P and we'll call the line L1. Now, if I wanted you to tell me the distance between them, there's a lot of different answers. The distance between them could be measured like this, or it could be measured like this. Or remember, that line is actually infinite in length, so there's an infinite ways of describing or measuring the distance between them. But what I'm looking for is the shortest distance between them. Do any of those lines that I've drawn in red look like the shortest distance? Not to me. Let's get rid of them and see if you can visualize how I should draw the shortest distance from P to line 1. So hopefully you envisioned something like this. And in fact, that's pretty close to being accurate, because here's the first really important thing we need to know, that the shortest distance is along a path perpendicular to the given line. So the given line, here's a perpendicular line. So this new green line, let's call it L2, is perpendicular to L1, and that's how I know that this is the shortest distance. Okay, so here it is nice and neat. Here's point P, line 1, and I've drawn line 2 again. So really, when I want to know the distance from P to the line, I want to know the length of this line segment, or I want to know the distance from point P to this point right here that I'm circling. So let's give that point a name, and I think the name Q makes sense because, well, P and then Q. So this point here, called Q, is really the point that I'm interested in, because if I could find where point Q is, then I could find the distance between P and Q. Remember, this is a formula that you know. It's the distance between 2 points. So if I know point P and I can find point Q, I can find the distance between them. So the shortest distance is the distance from the original point P to this point that I've labeled Q. And what do we know about point Q? So cleaned it up a little bit. What do we know about point Q? We want to know a lot about point Q, so have a look at the diagram. What's important about point Q? Well, it happens to be the intersection between the original line L1 and this new line I drew called L2. So again, Q is the intersection point of the original line and this perpendicular line. So in order to find Q, we need to know a little bit more about L2. So review, what do we know about this second line? Two things. It's perpendicular to L1 and it passes through point P. So again, in summary, line 2 is a line that's perpendicular to line 1 and passes through point P. So all of those pieces put together are the pieces that we need to find the shortest distance from a point to a line. So let's summarize nicely. Here's a point P, and here's a line L1. And I want to know the shortest distance between them. So first of all, visualize it. Here's what we need to do. First of all, we have to find a line which we're calling L2. And that line must be perpendicular to L1 and also passing through point P. So let's draw that on the diagram. So I need a line that passes through point P and is also perpendicular to L1. Well, that looks pretty good for a quick sketch. So this line here, oops. So the line that I've just drawn, let's call it L2. And again, it needs to be perpendicular to L1 and it needs to pass through point P. That step 1 is to find this line. The next step is to find point Q. And again, point Q is the intersection point between L1 and L2. And then finally, once you have point Q, you can find the distance between P and Q by measuring or by calculating the distance between those 2 points. So in 3 steps, you're going to find the equation of a line, find the intersection of 2 lines, and then use the distance formula. So let's put all this into action with this question. It says, find the shortest distance from the point P. Well, it doesn't say P, but I'm going to call it P. Find the shortest distance from the point 6, negative 2, to the line 8x minus 5y plus 31 equals 0. So first of all, exactly like I said, I'm going to identify point P. And I'm going to identify the original line as line 1, 8x minus 5y plus 31 equals 0. So what do I have to do first? So think about the steps I just told you. The first step is we need to find the equation of L2. And again, what do we know about L2? L2 is perpendicular to L1 and passes through point P. Okay, so line 2. Well, every line starts the same way. It starts like this. And all I need to know now are 2 little pieces of information. I need to know the slope of L2, and I need to know a point on L2. And I already know a point, don't I? So if you look carefully, we know that L2 passes through point P, and therefore this point here is on L2. So I already know a point that L2 passes through. How am I going to find slope? Well, the other really interesting piece of information we know about L2 is that L2 is perpendicular to L1. And if it's perpendicular, that means we need to talk about slopes. So if I can find the slope of L1, so the slope of L1 is perpendicular to the slope of L2. So let's go ahead and find the slope of L1. That's our first step. So again, here's line 1, 8x minus 5y plus 31 equals 0. So there's lots of different ways of finding slopes. My favorite is to rearrange into the slope-intercept form. So in order to do that, I need to isolate the y term. So there's the y term, and everything else needs to go away. So negative 5y stays where it is. 8x goes to the other side where it becomes negative 8x. 31 goes to the other side where it becomes negative 31. Now that I've isolated the y term, now I need to isolate y itself, which means I need to get rid of negative 5. And because it's multiplication by negative 5, I need to divide by negative 5. So everything gets divided by negative 5, and I'm left with y equals 8 over 5x plus 31 over 5. So this is line 1. So the slope of line 1 is right there. The slope of line 1 is 8 over 5. Now, therefore, the slope of line 2, so the perpendicular slope, must be, take the negative reciprocal. So flip it upside down and change the sign. So this is now the slope of line 2. So if we go back, we now have a point for line 2, and we have a slope for line 2. And once we have these 2 pieces of information, now we can find the equation of line 2. So let's go to a clean piece of paper. Here we go. So line 2 has a slope of negative 5 over 8, and it goes through the point 6, negative 2. Let me just double check that I remembered all that. Good. And again, every line starts like this. Y equals mx plus b. And now I know that the slope is actually negative 5 over 8. This point represents an x and a y value that I can use to solve for b. So let x equal 6 and y equal negative 2. So y is negative 2 and x is 6. And now I just need to solve for b. So negative 2 equals negative 30 over 8. So reduce that fraction. Negative 2 equals negative 15 over 4. Isolate b. Negative 2 plus 15 over 4. Get a common denominator. Add these fractions together. Negative 2, negative 8. So 7 over 4 equals b, which means here is the equation of line 2. Woohoo! Here's line 2, and that was part 1, or step 1, of finding the shortest distance. So what's part 2? Do you remember? Now that we found line 2, we need to find point Q. Point Q is the intersection between line 1 and line 2. So let's go back and review. What does line 1 look like? Here's the equation of line 1 right here. So 8 over 5x plus 31 over 5. So line 1 is 8 over 5x plus 31 over 5. And line 2, which we just found, is negative 5 over 8x plus 7 over 4. So now we need to find the intersection between these two lines. So you could certainly use elimination. I would probably, if I was using elimination, get rid of fraction in standard form. I'm going to do substitution. So I'm going to say, I'm going to let y equal y. So collecting like terms, I'm going to move both of my x's to the same side. So negative 5 over 8x minus 8 over 5x. And I'm going to move all the non-x terms to the same side. And now I have some fraction stuff to do. Isn't it nice that we have buttons on our calculator for this? So using excellent skills with fractions or excellent skills with your calculator, you should get that negative 89 over 40x equals 89 over 20x. That's interesting. So solving for x, what do you want to do? I'm going to multiply this by 2 over 2 so that I have a common denominator, and then I can eliminate that denominator. So this is going to be 178 over 40. Then when I multiply both sides by 40, I get this, and I get x equals negative 2. So Q looks like this. I just have to figure out what the other coordinate, what the y coordinate is. So to do that, just go back to one of your original equations, either line 1 or line 2, substitute in the x that you know, and solve for y. So here's that math done for you. You're welcome to press pause, but I discovered that Q is the point negative 2, 3. Wow, we're coming a long way. So what's the final step of finding the shortest distance? So what's the last step? We need to find the distance from P to Q. So here's the 2 points that we have. Point P was given to us. We found Q just in the last step. So now we're going to use the distance formula right here, and we're going to find the distance from P to Q, which is the shortest distance from the point to the line. So here's the final bit of the question done for you. where we simply take the 2 points we know and sub them into the formula. And we find that the shortest distance is just over 9 units.